As part of our data collection this summer, we looked at a number of range sites, but we had this nice sort of set of data from the Loney range site, which is one of the most challenging range sites to reclaim or restore. And we had a data set that from two seeded projects, a pipeline and the buried transmission lines in the wind farm. And then we had this data set of this matted access. So we were able to do a comparison. The seeded areas, they were all seeded, minimal disturbance techniques. These were Marilyn Neville's projects. You can guarantee they were state-of-the-art. They were good seed mixes. They had a combination of native plant cultivars and wild harvested rough fescue. And then 9 years recovery. And then we also had these matted areas that had been recovering for 4 and 6 growing seasons after the mats had been removed. The projects were all right in this Pincher Creek area. They're in the north end of the Cardston Plain Eco District in the Foothills Fescue Natural Subregion. So all kind of in here in the Crow's Nest and Old Man watersheds. So similar plant communities. Primary restoration risks in rough fescue grasslands are invasive agronomic grasses, which love these rich, moist, deep black soils in this natural subregion, and noxious weeds. And these are present already as sort of background in these ecosystems just as from other land use practices, historic land use practices. They're a fact of life, but they can really jump on disturbances and take a plant community in another trajectory to something that's not native and not really recoverable that we know of. Then, as Monique showed, we get winter thaws and we get wind erosion that can really create challenges both for construction and also for reclamation. Oh, actually, I wanted to show you the picture on the right. This is a buried seeded pipeline. It's on one of the projects we were looking at. It was a small area that didn't get the adaptive management and monitoring and control for Canada thistle that 95% of the rest of this project did a very good job on. But it just shows you that left without that kind of tweaking after initial reclamation, you can end up with this long strip of in this case, Canada thistle that's now pumping out seed annually into a nice, healthy native grassland, further fragmenting the sort of death by 1,000 cuts. It's ongoing and something that we really have to work hard to prevent or at least try and minimize. And then on the bottom there, we have a picture of, this is a 2-year-old disturbance. This was an area that was matted. It's on sands in just east of Pincher Creek along the highway there. But there's been some use of this road after the mats are picked up, and in 2 seasons we've ended up with a lot of deflation in this sand site. So another, theoretically benign impact on native prairie that hopefully would have been recoverable, but it really takes that sort of adaptive management once you're in there to turn these things around before they become bigger problems. So, you see, we had, as I said, seeded pipelines and a wind farm, 9 years recovery each, and then these matted access trails at the base of these transmission lines. We did some samples around the tower bases and some along the right-of-way. We're not seeing any appreciable differences in response. So, when we did the analysis, courtesy of Ross Adams, our genius whiz kid from the U of A, what we did is all of the seeded sites are red, all of the matted sites are blue, and all of the undisturbed sites are green. And all I want you to take from this diagram is sites that are more similar cluster closer together. So what we were looking for is what are we seeing in terms of plant composition? Which are these treatments getting us back towards undisturbed? Are they clustering close to the undisturbed sites? Are they off doing their own thing somewhere? And as we see, the seeded sites are all the orange sites are clustering pretty close together, so they're behaving similarly even after 9 years recovery. The matted sites are also, for the most part, clustering fairly close together, and there's a little more overlap with the undisturbed. But the undisturbed is still also largely separate from these other treatments. That would be the avoidance treatment. the green. So we don't want to look at all of this. What I want to show you is that the range health scores at the bottom here, all of these this is the highest score for undisturbed land. So this is range health of healthy with problems. The other two are still healthy with problems. And these are both, I would say, best case outcomes for matting and for seeding. So they're both healthy with problems. Anything over 50% is healthy with problems. And the striking difference for me in the two treatments was these guys, seeded sites score a lot lower. There's a lot more noxious weeds on seeded sites than you would find on matted sites and on the undisturbed sites. Litter quantity was actually lower on the matted sites than the seeded sites, which to me makes some sense. After 9 years, all your reclamation grasses should be growing pretty well and litter production is going great guns. After 4 and 6 years, perhaps not. Or are those plants, maybe there's some compaction going on there, we didn't measure that. But we saw this on most of the sites that litter quantity is not that great on the matted sites compared to seeded or compared to undisturbed. Here's my other, I just got this data on Saturday, so this is kind of the rough draft. Another way of sort of analyzing the data and sorting it was to look for, it's another way of looking for which things are clustering closest together, which sites are most similar. So this dendrogram, cluster dendrogram, looks at all the plant community composition and puts it into clusters. From there we have 6 clusters that I've identified by drawing those squiggly blue lines between them. All of the seeded sites are pretty much, as we saw with that other diagram, clustering together. And they are the least similar to the undisturbed sites. The matted sites in blue, they're clustering somewhat with the undisturbed sites. And so I wanted to look at these clusters a bit more. So for the undisturbed sites, they are native plant communities. They've got prairie, oak, grass, rough, fescue for cluster 5. Cluster 6 was more of a shrubby community, so it's got creep and juniper, shrubby cinquefoil. There is very little bare soil, so 0% for one and 2% average for the other. And they're both scoring healthy with problems. And as far as introduced species cover, like both of these native plant communities have a background level of Kentucky bluegrass at 5%, and that is pretty typical. It's an incredibly sort of pernicious introduced grass that I think it used to be called white man's foot grass. It's very unusual to find places without it, and a real treat when you do. So it's there, and it can cause big problems. When we look at the seed sites that were, the clusters that were primarily composed of seeded sites, what we find is that they are dominated by Kentucky bluegrass. 38% cover of Kentucky bluegrass on one, 20% on the other. And then we're seeing some of the seeded grasses that are also prominent as well. So green needlegrass is a very common and quite aggressive or persistent native plant cultivar, and then we've got wheatgrass in there as well. So on these sites, they are really what we would call trending to modified plant communities. It would be a real challenge to back this up to a typical rough fescue grassland native plant community. They're both scoring unhealthy, even though there'll be low cover of things like rough fescue in these clusters that have come in with the seed mix or have come in from the seed bank or remnant clumps that were put back. But they're not the dominant species in these communities. Litter cover is good, about 31% cover. And bare soil, like in the undisturbed, we had 0 and 2%. This is not bad for the amount of bare soil on a seeded site after this many years, especially in such a windy area as this. When we look at the matted sites, what really sticks out for me, and I think one of the real benefits of matting is that the dominant species are still what you would find in your native plant community. So it's rough fescue and western porcupine grass. Those are two of the real late seral, long-lived species in native grasslands, in the rough fescue grasslands. We've only got 2 or 3% introduced species covered. Range health, healthy with problems. Bare soil is also it's kind of equivalent to the seeded sites. And our litter cover is doing pretty well. So this is just cover. This is squashed litter on the surface, or if you're just looking straight down, how much litter do you see? The other thing we look at is litter quantity, like volume, which gives us a better idea of how much biomass is this grassland producing. It's something Tanner spoke to on the Twin Rivers project. So this is just a visual for when you remove matting. So this would be a rough fescue tussock, and this one died, so it didn't recover from matting. This one here, you can see the outline of where it was crushed, but we're getting some recovery of the rough fescue plants, but the vigor is reduced. So this is one of the towers that Monique was showing us. This is on Pecani lands on Kettle's Hill. This was in a pasture that has very little grazing. It was 100% for range health, really a beautiful grassland on the upper slopes of the hills. And this is what the tower base looked like the first growing season. So this is also an ideal scenario for matting. This area was matted during the winter, a little bit into the spring, and then the mats were off. So they're off by the time growing season is in full swing, and that's important. So we can see all the greenery coming up through the little bit of soil that's left there. And the only sort of disturbance, this was an older type of footing. It's a concrete caisson. And soil was brought in to put around the bases, and unfortunately that soil brought in a bunch of undesirable species. So in the middle of this area where a huge effort went into conserving and protecting the native grass surface, unfortunately there wasn't the same level of rigor by the contractor who brought soils in, and they brought in crested wheat, leafy spurge, and intermediate wheatgrass, which is really, you know, the attention to detail is super important on these projects. And given that it has been brought in, you know, early intervention would have been nice, but what we have now after 9 years is there's a little problem around the base, but honestly the rest of this is a really quite amazing result. We have a range health scores of 83%. This is another picture of that area. It was a steep slope, so gravel was used instead of the wooden mats. And the tower is actually at the base there. And then this is what we're seeing 9 years later. This grassland is in great shape. In fact, Stantec did some monitoring, I think a year or two after construction, and they had put in some waypoints for where they had been looking at the matting. And when we went back up the hill to try and look at this stuff, we thought there must be something wrong with the waypoints because we couldn't see any visual impact for where this matting had been placed 6 years ago. That's on a very healthy site. This site has more brome in the fescue grassland, and so what we're seeing is where there is already an invasive species established, this rhizomatous smooth brome was the first thing to capitalize on that disturbance once the mats were removed. So there's more brome, which is the kind of dark greeny purple stuff, whereas the fescue is over here. It capitalized on that disturbance on the access. So there are a number of variables that go into whether matting is going to be successful or not. The range site, the drier range sites with poorer soils are not going to have the same issues that these rich, moist, loamy soils have. Grazing pressure makes a big difference. Range health, as in this example, where if you've already got some brome or timothy in the pasture, it's going to jump on that surface disturbance and invasive species. But I think a real pitfall is when matting is used. If something's matted through the summer, plants are going to be killed. I don't have any good monitoring sites to show that. I'm sure there are some out there, but I would just challenge you to put a sheet of plywood on your front lawn on the nicest part, leave it there for 6 weeks and see if it just bounces right back. So there are limitations to the use of matting, and they don't always jive with the time frames that are needed by industry to do their construction. So it isn't there's no glib, oh yes, it's matted, it'll be fine. And then weed seed banks and weed introductions. Unique mentioned bringing in sand, for instance. Well, where did the sand come from? Sand and gravel pits can often be sources of noxious weeds, particularly things like downy brome. So yeah, I think it's really important to have a good environment group going with industry and good environmental monitors, good environmental inspectors who understand all the implications that can go, like things that can go wrong and what to be looking for. And also adaptive management. I really think that's critical. That first 1 to 3 years, once everything's gone and the initial reclamation is in place, is really important, particularly in Foothills Fescue grassland. You can tweak an outcome, you can tweak a direction in the early years that you may not be able to do in the later years. Here's an example where this is an area that was matted for 3 weeks in midsummer. It's an access trail to a directional drill site across the Crow's Nest River. And it's been recovering for 9 years. But this pasture hadn't been grazed for a very long time. So it's still, I put in some tiny little blue lines, maybe you can see them, maybe not. This was the access trail. And so 9 years later, you can still see a difference between on and off. And if you dig down, there's still a thatch of litter, or compressed thatch that was under the matting. And what that's done is inhibit the recovery of ground cover and of the low forbs and grasses. They've been smothered by this thatch. But you are getting the bigger, tougher things like buckbrush, and some of the bunch grasses have been able to poke through. I still think this is a far better result than if it had been stripped and seeded. It's just a matter of scale, but really I think matting is a great choice for a situation like this. This was the same spot, but just the other side of the fence. So this has had no grazing and big litter buildup. This side has certainly recently had quite heavy grazing. It's still actually rough fescue dominated, but it's been hit quite hard. But we don't see any litter buildup here, any thatch buildup, so perhaps the grazers broke it up, which would be a good thing. Or perhaps it was never there in the first place. This side had 100% range health score, this side had 41, both on and off. So unhealthy, but that's really a result of grazing and not from the matting. So the matting, I think, has great potential to retain native plant community composition and structure. There's some reduction in structure. We often see with seeded sites like part of grassland resilience and integrity is structure. So you'll have tall grasses, mid grasses, low grasses, or shrubs, tall grasses, low grasses, and then your ground covers like moss lichen and little clubmoss. With the seeded sites, we are seeing reductions in sort of 2 layers of structure, with the matting 1 to 2 layers, often sort of a suppression of the tall grasses is what we were seeing. So, but we still get more retention of structure and diversity with matting as opposed to seeding. And it increases operability clearly on native grasslands. There's less potential for non-native species introductions and possibly less erosion potential as well. I'm thinking more like wind erosion once that matting is taken off. I think those grasses are springing back fast enough and there's enough of a root mass and a thatch that you're going to get a response fairly quickly, and I don't think we'll have, well, it's hard to say, it depends on the soil. Clearly we saw in that sand that with ongoing use it quite easily scoured out. But the other advantage of matting is also that you haven't disrupted that soil structure. So you still have a lot of root biomass, root biota, holding that ground in place. So our sponsors for this year, we're very grateful to Prairie Conservation Forum, who gave us and the Alberta Eco Trust, who really gave us the cash to make this work happen this summer, and to Altolink, which funded the matting work on their lands. SRD provided a lot of help in kind, and Tanner Broadbent helped us out as a volunteer contribution from SRD. And then there's the survey team I'd like to thank, and also all the support we got with access, both from landowners and from MFC and Max and Altolink.